Give you a presentation on how to simplify your rugged high-performance edge server based on COM-HPC Server computer modules. I've been in the embedded market for 20 years now and have been focusing more strongly on infrastructure and networking since some years, specifically about rugged edge servers. In this presentation, we will explore how computer modules based on open standards can simplify the development of rugged edge servers. So the focus is on providing an in-depth understanding of the COM-HPC server platform and how its modularity, flexibility, and scalability can benefit edge computing applications. Starting with the infographic of edge server facts, continuing with the module's concept and benefits, coming to COM-HPC server definitions, the evolution of COMs, positioning of the COM standard, infrastructure network applications, showing the modular hardware setup and benefits, going to embedded design services, then scale your server family with one carrier board, then COM-HPC server examples of ecosystem, and at the last point, some insights of the upcoming A-Ready solution for infrastructure, and then having a summary. So the goal of the presentation is to provide a clear understanding of how COM-HPC server platforms simplify edge server development by leveraging modularity and open standards. We will cover the technical advantages, market potential, and practical applications of this technology, highlighting how it addresses the challenges of modern edge computing environments. In this slide, we will take a closer look at the market figures and technological possibilities of edge servers. So the graphic provides us with some impressive insights into the potential benefits and future market for technology about edge servers. First, we see that transitioning to edge servers can result in significant cost savings. By utilizing computer modules, costs can be reduced by up to 50% compared to a full system custom replacement. Additionally, using smaller server modules offers 56% space savings compared to traditional E80X motherboards, which is particularly advantageous in environments with limited space. Another important trend is reflected in data processing patterns. According to Gartner, by 2025, around 75% of data will be processed outside of the centralized data centers. This highlights the increasing importance of decentralization and moving computing capacity to the edge of the network. From a technological perspective, edge servers are built to operate in extreme conditions and rugged, harsh environments, with a supported temperature range of -40 up to +85 degrees Celsius. These systems are robust enough to be deployed in challenging environments without the need for air-conditioned data centers. Furthermore, edge servers feature extremely low response times, ranging from 1 to 10 milliseconds, which is crucial for real-time applications at the edge. In terms of performance, modern edge servers like the COM-HPC offer as a standard 1077 GB per second bandwidth, supporting networks with up to 1040 GB per second and 200 GB per second, ideal for high performance applications. Finally, market forecasts show that the edge server market is set for strong growth. By 2027, it's projected to reach $101 billion with a compound annual growth rate of 17.8%. So in summary, Edge servers provide substantial benefits in terms of cost, space, performance, and market potential, and they are becoming an increasingly critical part of modern network infrastructure. Let's have a look to the concept of computer models and some benefits, where you see here in between the CPU module with the standard PC core functions, which is cooled with a heat spreader to interface to the system cooling. There we have different options, even in the COM-HPC server class and the high performance class, to cool it in a passive way with heat pipe heat spreader and heat pipe cooling options to bring out the heat of the processor directly to the metal box and metal rack chassis. And the computer module here is connected. You can see it with the white connectors, the 2x400 pins. It's connected to the carrier board. And the carrier board with the customer specific critical IPs and special function and sizes that are possible can be handled from the customer, or the customer gets a kind of design in carrier training to have this IP in his hands. And we see, especially in infrastructure, in critical infrastructures, customers are looking for having this IP, intellectual property, with custom features and know-how on the carrier, in their hand, in their company, in their R&D, in their country. So the model concept is a buy-in decision from a purchase perspective for the customer. And so it gives the opportunity to reduced inventory and development cost, and of course to a faster time to market, to switch very fast to new technology, to new interfaces than you can develop on your carrier board, and the fast switch to next generation or higher performing processors with a new computer module that you connect to still the same carrier board. But let's have a look here on the benefits of the computer module standards. So the advantages of the open standard computer modules and not the proprietary computer standards. So you have a faster time to market, as you can focus on your own customized project and on your specific market, and you don't have to focus on this really complex processor design on a module or on a board. That means you also have reduced development costs. You don't have to design this complex computer board, and you have a scalable product range, as you can build a complete product family, for example, with one carrier and several different computer modules with several different performance levels or efficiency levels, from mobile products to portable and standardized systems. So that makes it very interesting. And it allows to focus on system features. So all the specific customized features that you need specifically in your project, you can build and design them on the carrier board, on the customized carrier board, where CONGATEC can support you with trainings, with special lab views on your customized carrier, and where you can start with a standard evaluation board from CONGATEC, where you have all the features, all the possibilities that can come out of the pin, of the signals, of the processor, of the computer module design. And you can combine x86 and ARM designs on the same carrier, as it is an open standard, and on each of the connector pins it's always the same signal, and it stays forever on this specification and open standard. You can react faster on market trends. You can switch from one generation computer module to the newer generation of a processor version on the next generation computer module that is designed, and so you can always stay on the latest technology in your project. Especially since Corona, the second source philosophy got a very strong benefit, where you really had in the chip shortage problems sometimes to get your chip design, and here you really can switch very fast from one vendor to another vendor in your design, which is a very good possibility. And of course you can minimize your inventory costs at all. The evolution of open computer module standards show you the long history of more than 25 years, the strength and the sustainability that the standards bring, that were driven off the primer data bus at the beginning based on the ISA bus, then in the ETX time based on PCI bus, bringing the performance of the first Intel Pentium processors and Windows operating systems to the embedded and industrial market. Then it went over to the primary data bus based on PCI Express, the well-known and successful COM-Express standard. And now it came even to a higher performance possibility with the market requirements asking for more PCI Express lanes up to 64 and 800 pins. That gives you a lot of possibilities and interfaces, headless for even more network requirements, and up to 8 DIMM memory sockets. That's the latest computer module standards. That's the COM-HPC Server standard module version, where we have a deeper dive today. Let's have a closer look about the positioning of the computer module concept compared to, for example, single board computers and full custom design, from low volume to high volume. So in this simplification, you see in the middle that computer modules are mostly used in a project range of about, for example, 1,000 units up to 20,000 units. But of course, there are also some very specific or complex designs where it makes sense to do a project based on the computer module standards, even if the project has only a unit of 100 pieces. That's also possible. And of course, it's not stopping at a project unit size at 20,000 units. Sometimes the project of computer module designs are even much higher, for example, up to 40,000 or up to 50,000. But that's just a simplification to see the positioning. And so starting from the left side, when it makes sense to use a single board computer, or in our example, when it makes sense to use a standard server board. So it's off the shelf in a single board computer version or standard server version, and you have some minimum possibilities with customization, but not that much. And so it's very easy and very fast time to market possible. And coming to the computer module, so it's an off-the-shelf module, and you can do all your customization on the carrier board, starting with a standard one with an eval board, and then featuring your customized special carrier board. So you have a high customization level, which is possible here on the standard, and you have the most scalable solution if you stay with the computer module standard. If it comes to a full custom design, so this is really a design to requirement solution. You have a full customized level. So here we talk about higher than 20K or 50K or 100K units, where each component needs to be calculated that is in this design, and 1-2 cents can kick out a component and be the reason to make a full custom design in high quantities. And it's a high NRE or non-recurring engineering cost for each generation that you have to think about. On the application side, we have two different classes. On the one side, based on the computer model concept, going into different kind of edge servers, and on the other side, different kind of RAN telecommunication servers. On the edge server side, different examples here like firewall servers, where the model concept is a big win because you can do a lot of customization on the carrier board, where at the firewall, for example, you want to have two model systems with two processors that fit into one rack, and you can do customization on the carrier board that the size fits into the rack. Or for example, in customized VM, virtual machine edge server or centers, where you have a hypervisor, for example, and separated operating systems for different use cases all together in one hardware system. And another case is AI edge servers. Here, for example, on a customized carrier board, you can connect with different kind of AI accelerator chips or cards on the PEC connector, PCI Express, or for example, as well on the M2 connector or on a mini PCI Express connector as well. So you have a huge flexibility, and especially as well on rugged edge servers, where it's about extended temperature, shock vibration proofed, and you have an extremely strong rack or body for the system. And on the RAN side, we see different use cases closer to the radio server unit area, or also to 5G RAN platforms, where you have three different system units. The first one is called the radio unit, the RU unit. Then you have the distribution unit system and also the central unit system, where the COM-HPC Server Module system fits well. Here you can see the latest version of COM-HPC Server Modules, which are based on the Intel Xeon D1800 and D2800 processor family. So these Intel Xeon processors have up to 22 cores and 44 threads. And they are really improved in efficiency, performance, weight, and cost, and available in the industrial temperature range of -40 up to 85 degrees Celsius. And in a kind of infrastructure network set, you can combine it together with the optimized edge server application board, which is a high density micro ATX simplified integration version, and really was designed together with market experts in the server market. So you can see it's really featured with a lot of possibilities on a compact size, the micro ATX server carrier board. Let's delve into the key highlights of COM-HPC design, which is an essential infrastructure element for modern edge servers, AI and 5G applications. You can see 6 critical performance metrics that make these designs stand out. First, maximum capabilities are highlighted for use in edge servers, AI and 5G applications. This shows the COM-HPC design is ready to support next generation technologies that require rapid processing and distributed computing across various environments. Maximum AI capabilities, supporting up to 64 PCI Express lanes with Generation 6 compatibility. This extensive input-output capability allows for high-speed data transfers and connections with multiple peripheral devices, a vital requirement for high-performance computing tasks. Moving on to maximum performance, this design supports high-performance CPUs with a TDP thermal design power of over 200 Watt. So such power enables these processors to handle large computational loads, making them ideal for demanding tasks like AI inference, real-time data analysis, and complex machine learning models. In terms of bandwidth, the COM-HPC design offers up to 8x25 gigabit Ethernet connections, ensuring high-speed network communication that can handle massive amounts of data with minimal latency, essential for real-time edge computing scenarios. On the memory front, the design supports up to 1 terabyte of RAM, providing significant memory capacity to run multiple processes of workloads simultaneously without performance degradation. This is critical for edge servers running AI workloads which often require substantial memory resources. Lastly, the maximum ruggedness of this design stands out with an industrial temperature range support of -40 up to 85 degrees Celsius, meaning it can operate in extreme environment conditions. So this ruggedness ensures the servers can be deployed in diverse, harsh environments with the need for specialized cooling systems. So in summary, this shows that the COM-HPC design is pushing the boundaries of edge server performance with its robust capabilities across multiple key areas, from processing power to environmental durability, making it a critical component in modern data infrastructure. CONGATEC design services provide flexibility and customization options for edge server solutions. First, we have customization. So this includes tailoring computer modules, carrier boards, and cooling solutions specifically to the needs of your project. So for example, you need a frozen BIOS that needs to stay forever as it is. So this customization ensures that the hardware fits seamlessly into your infrastructure, optimizing performance and efficiency. Design, which emphasizes the creation of custom carrier boards and full hardware cooling solutions. These bespoke designs help ensure that the hardware is specifically engineered for the particular use case, offering both better thermal management and more efficient operation. Manufacturing is another crucial part of these services. It ensures efficient, high-quality production that aligns with industry standards. This focus on manufacturing guarantees that the components are built to meet specific performance requirements while maintaining high reliability and durability. The modification service focuses on the software side, offering customized BIOS, UEFI, or firmware features and settings. This allows for greater control over system behavior, enabling you to tweak the performance of features for specific applications and environments. Finally, system integration is supported through a network of partners, technology partners, for example. This involves testing, certification, and integration with other systems, ensuring that the product is fully functional and certified to work within a variety of environments and use cases. So these services together offer a comprehensive approach to designing, modifying, and integrating edge server solutions, providing maximum flexibility and performance for your specific needs. Let's scale your server product family using a single edge server carrier board like the COM-HPC Micro ATX application board. This strategy allows you to create a range of products with minimal variations, maximizing flexibility while minimizing complexity. The example here is to leverage one edge server carrier board across multiple product configurations with 3 housing variants, including a rugged housing version, a 1U and a 2U rack, and 3 computer on module server versions. You can create 9 different catalog variants. This enables you to tailor your products to meet diverse market requirements while using a standardized foundation. By utilizing this approach, you simplify the process of expanding your product line, allowing for rapid scaling while keeping costs low and production efficient. It demonstrates how a single edge server carrier board can be integrated into different housing configurations, supporting multiple application scenarios without the need for redesigning the core components. So this approach not only saves time and resources, but also allows for a more agile product development cycle, empowering your team to address different market segments quickly and effectively. COM-HPC provides a complete COM-HPC server ecosystem, which includes 2 Intel Xeon-D-based modules, along with essential components such as cooling solutions, memory, carrier boards, and LAN enabling kits. These components are carefully designed to work seamlessly together, allowing for the fast and flexible design of edge servers that are both high-performing and scalable. Each part of this ecosystem plays a crucial role. The cooling solutions ensure optimal thermal performance, even in demanding environments. The modules provide the processing power needed for advanced edge computing tasks, while the memory, components, and carrier boards ensure smooth data flow and system integration. Finally, the LAN enabling kits make sure that these servers can handle high-speed network connectivity, a key requirement for modern edge applications. So the LAN enabling kits really help also in your decision and first tests in your lab. This comprehensive ecosystem supports the rapid development of custom edge server solutions tailored to meet a wide range of use cases, from industrial applications to real-time data processing and AI-driven inference tasks. By integrating all these elements, COM-HPC simplifies the process of building high-performance edge servers, helping customers bring their solutions to market faster and more efficiently. The difference is made by our cooling solutions. Here I want to point out 4 examples of our COM-HPC server modules based on Intel Ice Lake D, the Xeon-D processors, where you have a standard heat spreader or a passive cooling solution version as well in an active way. And especially I want to point out our heat pipe adapter, where you can bring out the heat of the processor in a very fast way to your metal chassis to cool it down. The platform provides unlimited freedom for infrastructure, meaning that it can be tailored and scaled to fit a wide variety of industrial and edge applications. So the design helps to break out of constraint restrictions, enabling more flexible deployment in environments with demanding physical and technical requirements. A key feature of the platform is its massive data throughput with the lowest latencies, which is critical for real-time data processing and edge computing tasks where rapid responses are essential. Additionally, the platform includes a secure FEC forward error correction accelerator, ensuring robust and reliable data transmission by correcting any potential errors during communication. From a technical standpoint, the platform supports high-efficiency heat pipe passive cooling example, which helps to maintain optimal thermal performance in harsh environments without the need for active cooling systems. It is powered by a 22-core module, providing substantial computational power for high-performance tasks. Optionally, it includes SyncE DPLL oscillator component on the module, ensuring precise synchronization and timing, which is especially important in telecommunications and other time-sensitive applications. In terms of memory, the server platform can support up to 1 terabyte of DRAM, providing sample space for complex workloads and applications. Finally, it features 8x25 gigabit Ethernet, enabling high-speed network connectivity and ensuring that the system can handle substantial data traffic with ease. So overall, this rugged Edge server platform, as an example, offers a robust high-performance solution that is well suited for demanding edge computing environments, providing flexibility, power, and reliability. This is a customer example of Thomas Krenk Company using the Congatec COM-HPC Server Modules and Micro ATX COM-HPC Server Carrier Board. So it's an example as one of thousands industrial edge server applications in the market. This example here supports modern AI workloads, particularly text-based AI such as large language models. The Edge server here offers secure hardware for executing text-based AI applications, providing a reliable platform for business that require real-time processing with minimal latency. LLMs such as ChatGPT are revolutionizing the fields of data analysis and automation, offering new ways to interpret vast amounts of data efficiently and accurately. However, the dependence on the cloud of LLM operations comes with its own set of challenges, including data protection risks and availability concerns. Many organizations find that relying on cloud infrastructure introduces vulnerabilities, especially when dealing with sensitive or confidential information. This server platform offers an on-premise solution, mitigating these risks. While running AI models on-premise can be complex and expensive, the rugged Edge server provides a more streamlined and cost-effective alternative. The device is ready to use and comes with dedicated hardware acceleration specifically designed for LLM inference. This ensures optimal performance when processing complex AI tasks, enhancing the speed and efficiency of inference calculations. This Edge server example enables businesses to process confidential data locally with maximum performance, efficiency, and trust. By running LLMs on-premise, organizations retain control over the data while benefiting from cutting-edge AI technology without the risks associated with cloud reliance. This is particularly valuable for industries where data privacy and trust are critical. The heart of this infrastructure kit is the COM-HPC Server Module powered by Intel Xeon-D processor. The kit also includes the application carrier board in the Micro ATX form factor, providing the flexibility and compatibility with various components. Key components include memory DIMM socket modules, offering the potential for high capacity memory to ensure smooth operation of multiple workloads. Additionally, the cooling solution ensures efficient thermal management, keeping the system running optimally even under high performance conditions. The system comes with a NVMe SSD flash storage for high-speed reliability storage, crucial for quick data access and storage requirements in real-time applications. Moreover, the kit includes on the flash storage the A-Ready infrastructure network software stack, featuring Linux, virtualization technology, OpenSense security, and other tools, making it easy to implement secure and efficient virtualization solutions right out of the box. This virtualization ready kit provides a highly integrated out-of-the-box solution for developing and deploying powerful, secure and efficient infrastructure systems suitable for edge computing and data center applications. The new A-Ready Congatec solution. It represents a fully integrated application-ready platform built on computer-on modules. At the base is the COM hardware layer, which includes the core components such as processors, memory and networking interfaces. This hardware provides the computational power and connectivity that form the basis of any edge computing or industrial system. Above that is the virtualization layer. Hypervisor module, our innovative firmware feature, enables the system and workload consolidation of multiple operating systems and applications on a single physical module to make full use of all resources. It's already pre-installed and just needs to be activated. OS layer, operating system layer. This layer runs the operating systems that manage the hardware and provide a platform for higher level software applications. Multiple operating system instances can run concurrently in a virtualized environment, providing isolation and dedicated resources to each application. The software layer sits on the top of the OS, where specialized applications for different use cases can be installed. Examples include software for AI processing, energy management, human-machine interface, real-time control, data management, firewall, security, and so on. This layer enables specific functionalities required by different industries and applications, such as advanced data analytics, automation, and control systems. At the top is the customer application layer. This is where end users interact with the system, deploying and running the system tailored to specific needs. This could involve AI-driven processes, automation tasks, data visualization tools that depend on the underlying layers for performance, reliability, and scalability. So the custom software is here. Normally the customer provides his customer application as an ISO image file to integrate and install it in the production and assembly process of the modular system. In summary, the A-Ready platform is a comprehensive multi-layered solution that integrates everything from the hardware foundation up to the customer-specific software applications, providing a robust and flexible environment for industrial and edge computing deployments. Here you see a comparison between three different levels of solution readiness. On the left side, computer and modules, then A-Ready.com, and on the right side, a fully integrated system. The focus on the intermediate solution, A-Ready.com, shows a strike and a balance between basic hardware and a fully operational system. A-Ready.com sits in between these two extremes. It offers significant advantages over the basic computer and module by providing a virtualization-ready platform with integrated mass storage and pre-installed operating systems and software, which speeds up the deployment process. However, it may still require some additional components and final configuration to run independently. This makes it ideal for users who need a faster solution but still require some level of customization or additional integration. The benefit of aready.com lies in its balance between flexibility and readiness. It provides the necessary hardware and software infrastructure to shorten the development and deployment timeline while allowing for the integration of additional components as needed. This makes it an attractive option for businesses looking to implement edge computing solutions quickly but with room for further customization or scaling. So in summary, aready.com offers a solid middle ground with much of the integration work already done, allowing users to focus more on customization and application deployment rather than hardware setup. This slide presents an overview of the upcoming software and system options available for the Congatec Aready Server application platform. So it highlights how different layers of software, middleware and operating systems can be tailored to meet specific customer needs in terms of network management, virtualization, cloud technology, security and more. The solution is designed to provide flexibility across various infrastructure and cloud environments, supporting modern applications such as data management, containerization and collaboration tools. At the same time, security and remote management play a crucial role, with integrated firewall and monitoring systems to ensure safe and reliable operations. Additionally, customers are given the freedom to choose from multiple operating systems, including popular options like Linux, real-time operating systems, Ubuntu Server, or even Windows Server, depending on their use cases and technical requirements. This flexibility in software integration allows the platform to be optimized for different applications, whether for edge computing, industrial automation, or cloud-based services. In a sense, the platform offers a ready-to-use, highly configurable server solution, equipped to handle a range of modern enterprise workloads, ensuring security, flexibility, and scalability. For more information, visit our Infrastructure Network landing page, where you can find different information about several values and overview about which ecosystem is the right one, information about recommended products and different kind of papers like white papers or case studies and videos if you don't have time to read. Throughout this presentation, we explored various key aspects of the COM-HPC server platform and how it enables a more efficient and flexible approach to edge server development. We started by presenting edge server facts, laying the foundation for the importance and market potential of the edge computing, and finished with the upcoming Aready solution for infrastructure, which provides an even more flexibility and streaming of edge server deployment. So the goal was to demonstrate of how COM-HPC server platforms simplify edge server development through open standards, modularity, and customization. We showed how this approach reduces costs, shortens time to market, and supports future edge computing needs, providing a clear path for businesses to adapt this technology effectively. Thank you for your attention throughout the presentation. We hope you found the insights valuable and inspiring for edge server projects. Please feel free to ask any questions now, and we are happy to provide further clarification and discuss any details.
Thanks, Željko, for that great presentation. We already have several interesting questions, but I want to Let our audience know that there's still time to submit your questions, so use the chat tab up on your right-hand side of your screen. So, okay, with that in mind, Shelko, are you ready to answer some questions?
Yes, of course.
Excellent. Let's see. The first question is, how does COM-HPC differ from other computer module standards?
So it's the latest computer module, and open standards computer module have a very long history.